So what we're doing here is using our 12 by 12 array to simulate the universe. And what we're emulating is what happens when a spaceship reaches the edge of the known universe. And in this case we're starting off at pixel 6 on the x-axis, 5 on the y-axis, and we're saying that's the centre of our universe. We randomly generate a colour, we randomly generate a direction, the spaceship heads off in that direction, and when it reaches the edge of the universe it basically just keeps on trucking, heading out into the great beyond. We don't know what happens to it after that. So like I say, that's the first scenario. Now let's look at scenario number 2. Okay, in this scenario our spaceships bounce off the edge of the universe. So we're starting here with one spaceship heading east and one spaceship heading west, and when either of them hits the side of the universe they ricochet back and head in the opposite direction. Well, this is another example of the bouncing off the edge of the universe scenario, but in this case we started off with one spaceship heading north and one heading south, and once again when they hit the edges of the universe they bounce back and head in the opposite direction. And this is one final example of our bouncing off the edge of the universe scenario. In this case we started off with one ship heading in a northeasterly direction and the other one heading in a southwesterly direction. And you can see that they bounce off the 4 sides of the universe and just keep on their merry way. So this is a wrap up of the edge of the universe scenario. We've got all 6 spaceships in play. 2 are going backwards and forwards horizontally, 2 are going backwards and forwards vertically, and we've got 2 going diagonally in different directions. In this final scenario we're considering that the universe is curved back on itself. So the right hand edge we can imagine as being wrapped around in a vertical cylinder and meeting up with the left hand edge. So when the red ball exits the screen stage right it returns screen stage left, and when the yellow ball exits in the westerly direction it returns from the east, and so they just keep on going and going and going. So we're still considering that the universe is wrapped around, but in this case we're looking at spaceships that are going north and south, and so we can imagine the universe as being rolled around in a horizontal cylinder, so that the top edge wraps around and meets the bottom edge. So as the blue spaceship heads off at the bottom it returns from the top, and as the green spaceship heads off at the top it returns from the bottom. Now this is the example where our spaceships start off one heading northeast and the other heading southwest, but in this case when they reach one of the sides they appear on the other side, and when they reach the top they appear on the bottom, or when they hit the bottom they reappear on the top. And this is the big wrap up from our third scenario. In this case we start off with one spaceship heading north, one heading south, one heading east, one heading west, one heading northeast, one heading southwest, and again we have a curved universe. So when a spaceship exits from the right hand side of the universe it reappears on the left. If it exits from the left hand side of the universe it reappears on the right. If a spaceship exits from the top of the universe it reappears on the bottom. If it exits on the bottom it reappears on the top. And similarly for the ones that are heading diagonally, whichever side or edge they head off, they come in on the corresponding side, the other side of the universe. Now all of these experiments actually have a meaning, because we're going to use the array to implement a version of Conway's Game of Life. And in that case we have to decide what we're going to do with the cells at the edge of the universe. Is there going to be a boundary outside our Petri dish, or is it going to be curved where one edge wraps around and meets the other edge. And this is what we'll be looking at next time.